The topic of this video is finding the inverse of a function, but we've gotten very detailed into the work that we're doing with this topic, and specifically we are dealing with equations and checking if two functions that we believe are inverses are actually inverses of each other. This is how we can check our work for an inverses problem when we are using equations. Let's take a look at this. To check if two functions are inverses, show that when you compose them in either order, you get x. So one way of thinking about the word inverse is kind of like the mathematical version of opposite. Up and down are opposites. Left and right are opposites. In a math class, we have operations that we also recognize as being opposites. For example, add and subtract are opposites. In a math class, we call those inverse operations. Adding is the inverse of subtracting. Multiplying is the inverse of dividing. Cubing is the inverse of cube rooting. There are many mathematical inverses. So, if we want to know if two different functions are inverses of each other, all we have to do is to compose them together in both orders and show that if x goes into the first, that x will come out the last. Here's a simple example of this. We have a function called the a function. Its job is to add 2. So if something comes in, you add 2, and then something comes out. Then we have this other function, the s function. Its job is to subtract 2. So if something comes in, we subtract 2, and then the new thing comes out. Obviously, adding and subtracting are opposites. So let's show that they are inverses of one another. Imagine we have our functions arranged this way. We have an input going into the add function, then whatever comes out will go into the subtract function, and then we'll measure what we get at the end. So if x goes into the function a, whose job is to add 2, then what comes out will be x plus 2. Then if x plus 2 goes into the function s, whose job is to subtract 2, then we would have x plus 2 subtract 2, which gets us the original x that we started with. This shows that these appear to be inverses of each other. But for us to know for a fact whether they are truly inverses, we need to be able to swap the positions of the two functions and still find that the x that we start with matches the x that we end with. Let's do that now. When x goes into function s, the subtract 2 function, what comes out is x subtract 2. Then when x subtract 2 goes into function a, the adding function, what comes out would be x subtract 2 add 2. The 2's cancel, leaving us just x. By composing two functions together, you are proving that they are inverses of each other. Now, how do we write this using algebraic symbols? Let's say you have two functions, and you believe that they are inverses of each other. The first one would be called f. The second one would be called f inverse. By composing them together in both orders, you can show that the original input x leads to an output of x. For example, f of f inverse of x equals x. If you can show that this is true, then that would be half of the work that you need to do to prove that these really are inverses of each other. Think about this conceptually. X goes into a function named f inverse, and what comes out is f inverse of x. Then that output becomes the new input for the other function f, and what comes out is x. The original input and the output match each other. We also have to be able to reverse the order. So f inverse of f of x must also give us x. What's going on here is that an input x goes into a function named f, and f of x comes out. That becomes the new input for our other function. So f of x goes into f inverse, and what comes out is x. Original input, final output, they match. So if you can show that f of f inverse of x equals x, and f inverse of f of x also equals x, then you have proven that your two functions truly are inverses of each other.